Hi everyone and welcome to this video. Today we will have this masonry wall and we will apply a static or a quasi-static load on this wall. Okay, so we already have the mesh model. For creating the mesh, that's covered in a different video. So first we want to fix the bottom. We can go to create entity and then go to set data, set node, create, and then here I will call it bottom nodes. I flip this model and then I select by element and propagate and select any elements on the lower surface and then apply. Now I will select again. I will create another node set on the top. So this one is top nodes. Then I will select by element, propagate, and select any element on the top. And we have this number of elements 896. We should remember this number 896 of nodes. This number of nodes, it's important to remember them. Then click on apply. Okay, next I will click on show, then clear this one and then go to keyword, click on all, then boundary, prescribe or boundary SPC set. Click on new, put one here, and then you can say fix bottom node set bottom nodes, and it is fixed in XYZ translation and also rotation XYZ. Then apply. Then we click on add. We want a new one. This is top nodes degree of freedom. So the top nodes will be only allowed to move in the Z direction. So it is fixed in all other directions. Okay, cannot rotate and cannot translate, but only in the Z axis it can move down. Okay, done. Now we have fixed the bottom and the top. You can see from here the bottom nodes here are fixed in everything and the top nodes are allowed to move only in Z. Now next we will define the load. So we can go to all and then go to define and then curve and then new. Okay, this is, let's say it is gravity curve. So when time equal to 0, gravity is 0. Insert. When time equal to 1 second, the gravity is constant. The gravity constant is this value. Insert. Okay, this value because we are using millimeters and seconds. So this is millimeter per second square. Then here we put the termination time. Maybe you want our termination time to be, let's say, 30. And then insert, accept. And if I plot, I will have this curve. This is the curve that I have. Okay, this is the gravity curve. Okay, the next one is the load. So the applied load on the top. So I click on add, then I will say load. Okay, this curve will be in kilogram. Okay, because I have the data in kilogram, so I will put it in kilogram. So the first point, it will be 0, 0, of course, and then the second point, the first point is 0, 0, insert. Then when time equal to 1, also we have 0, insert. We want to apply the force after time equal to 1, because from 0 second to 1 second, that's the period where the gravity is initialized. Okay, so we have this one, then we can put 2 here, and then this one is 8,000, insert, and then we put 3, this is 16,000, insert, and 4 second, 24, and we just keep doing this until we finish entering all our data. This is 32, insert, 32, and then 6 here we have 40, 7 we have 48, 8 we have 56, 56, and then 64. Now this is here 10, we have 64, insert, 72, insert, we have 12, we have 80 tons, then this is 13, here we have 8, insert, and then we have, okay, we have until 15, or sorry, we have 16, and then at 16 we have this value, insert, accept, and as you can see, the curve, maybe I made a mistake in the curve, maybe. So this is the curve. It should be actually a straight curve. Maybe there is a mistake in the points where I entered. Okay, so let us go over it again. 24, 32, 40, 48, 5, 6. Okay, here should be 9. And here should be 11. And here is 9, 10, and then 11. And then this is 12. I accept and I plot again. So if I plot, you can see it's just a straight curve. Okay, it's just a straight curve. So if the curve is actually straight, I do not need to put all the data like this. I just need to put the first point and the last point. So what I can do, actually, I can delete all the intermediate points. Then if I click accept, and then if I plot again, you can see it is the same curve. Okay, alright, so I click on accept. Now this is the force, or this is the what you call it, the mass. Okay, and it is in kilogram, but our units for mass is ton. So I need to divide this one by 0, by this factor, and then click on accept. Okay, now I have the load in tons, and our unit are in ton. So this is okay. Now I need to convert this one again to force. So I need to multiply this by the gravity constant. So I open my calculator, and here is my calculator. So this is the gravity constant, and I'll multiply by this factor already that I have. So I need to multiply actually by this value. So copy, put here, accept. So now the load actually in Newton. Okay, so accept, plot again. Okay, looks fine. Okay, next I will apply this curve on the node set number 2. So I go to all, then I go to define load. First I define the gravity body Z, and I just put the gravity curve, just accept. Now the gravity is applied for everything. If I, let's say I hide this, I hide the elements, and I click on here, load body Z, you can see this is the point, this is the load body Z, and it says this arrow is going to the increasing the height, or yeah, because the gravity load is related to the height. So when we go higher, the gravity load will be higher. Okay, that's why it's I mean, when we go higher, the pressure because the gravity is related to the height, so here it says the positive Z direction. Okay, now I go to load node set, select this one, top nodes, degree of freedom, this one, and then I click this, I have the gravity load, and then accept, done. Now if I click here, you can see it's pointing upward. I do not want that, I want it to be pointing downward, so I put negative here, then accept. Now the direction is corrected. Alright, before I proceed, I need to go here again, and no, not this one. I can go to create and check the top nodes, how many nodes we have. We have 8, 9, 6. So I need to say 8, 9, 6, and then I reverse this number, or I invert this number. I have this very small factor. So this factor, I copy it, and then I put it here in load node set, put it here, and of course keep the negative direction because you want the load to be downward. You paste that value and then accept. Why we multiply by this very small number? Because the load will be applied on each node, so we need to divide by the total number of nodes. Okay, now the load is done, the boundary is done. We go to the section and material. So click on all, go to section. This is just a standard solid or default solid element. Solid element, and then accept. Next I go to material, so go to all, click on material. There is material here, so I will use material number 096, which is this one, brittle damage. Click on number 1, click on new ID, sorry, and then we can go here and type brick. Okay, so the density is 16 E minus 12 because it is ton per millimeter cube. The elastic modulus is 4710 in megapascal. Moisture ratio is 0.12, and then this is the tensile limit and the shear limit. Okay, so the tensile limit is like the tensile strength, so 0.785, The shear limit is also 0.785. Okay, this one are for the reinforcement, and this is the fracture toughness and shear retention. This is not necessary, but if we have this data, of course it's better to put them in. Okay, this one in megapascal, this is megapascal. This one we do not have any units for it. Then we click on accept. Okay, next for the mortar we use the same material model, so click on add. Here we can say cement mortar. So the density, mass density of this guy 1800, A minus 12. This one, the elastic is 5085. The Poisson ratio 0.2. The tensile limit is 0.16 megapascal, and for the shear is 0.25. So as you can see, this is cement, and cement is very weak in tensile and shear. So click on accept. Okay, now we are almost done with the material properties. We have defined the tensile limit and the shear limit. Now we want to define the compression limit. So we go to 0, add erosion. Add erosion is here. So you can just click on alt format. It's okay. And then you click here, and now you want to define the compression strength for the brick. And the compression strength for the brick is 12 megapascal. And you put negative because we know that tension is positive and compression is negative. And you put it here in the minimum pressure, because maximum pressure will be positive. Minimum pressure, meaning minimum pressure, which is the compression, should be negative. Accept. Then click on new ID, or click on add. Then click on this dot, cement mortar, and for the cement this is minus 3.5, and then accept. Okay, for this one also we can use the alt format. Okay, done. Now go to model, go to part. These all additional parts need to be deleted. We only have 1, 2, 3. Okay, you can see from here we have 1, 2, 3. The rest are actually parts that do not have any elements in them, but still we need to delete them from here. But before that, we assign, or we link the material and the material mod. We link the section and the material model to the parts. So for the brick, it's a solid element, and it's a brick. Accept. For the mortar, it is solid element, cement mortar. And for the horizontal mortar is the same. Okay, now we just delete all these guys. Delete this load. I can double click here, double click to hide them, and I can show the elements. Okay. Now we have defined the load, we have defined the material. Now the termination, okay, the simulation control. So for the simulation control, I just need control termination. Control termination. First I need control termination, and it is, I think, 16 seconds. You can see the curve, the load curve. The termination time should be beyond this one. Okay, so the gravity curve can be until 17 seconds, or can be until 20 seconds, it's fine. And for the load, it is until 16 seconds. So the termination can be also 16 seconds, correct. Okay, now this is a 16 seconds is a very long time for the explicit solver. So we need to use the implicit solver. Okay, so go to implicit general, and here I put number 1 implicit analysis. The initial time can be 0.01. Okay, and then accept. Now implicit auto, because I want the time step to be adjusted, so it can go bigger or smaller, depends on how the calculations are stable or not. And then control dynamics. Here I can put equal to 1. Okay, because control implicit dynamic is easier to converge compared to the static analysis. So this one is like a quasi-static. Okay, next here for gamma I can put 0.6, and for this one 0.38. Okay, this one to apply some damping in the simulation or in the calculation, so we do not have any dynamic effects. Okay, so this is done. Now we go to database. So click all and then model. Sorry, click all, collapse all, and then go to the database. D3 plot, and here we can say 0.5 or 0.1. accept. Okay, it is 0.1 second, so in 1 second we will have 10 frames or 10 animation states, and the total termination time is 16. So we will have like 160 to 161 animation state. So here Control S, this one will pop up, and then we can save. Then I open the ls run, and I put it here, open, and then we can just run. So everything is working fine. Right now we just need to wait for the results. So that's all for today. Thank you very much, and see you next time. And bye bye.